In this problem, we're asked to look at a front-end loader that consists of a cab and motor unit that are connected at a hinge. And the hinge would be right here. So here's the cab, and here's the motor unit. And I just basically drew the cab with the bucket attached to it here. So we have the load in the bucket here, the gravity from the cab, and acting through its center of mass. The weight of the motor acting through its center of mass, then the reaction force from the two tires. So there's two tires here at each one, so that's why I have 2F here. And I probably should write 2F and 2FB here to just make that clear. And then at this pivot point here between the motor and the cab, we have this hinge. And so there's like a pin that goes through this and connects these two things together. And that pin will create both a vertical force, well, it'll create a horizontal force too, but there's no other horizontal forces acting in the problem, so that component would be 0. So we have a horizontal force and then also a couple here. And we really can't get anything more than just a couple because we don't know what this distance is, so we don't know what the force is actually on these two flanges here would be, but we can figure out what their combined couple is. So what I did is I did a free body diagram of the whole structure, of the whole front end loader, and such that the forces, the internal loads cancel out, and so we get 2 times the front wheel load, 2FA from the front wheels, 2FB for the back wheels, and then this total weight of the load, the cab, and the motor unit. And then I took moments about point A here, which is the front of the front wheels of the front end loader, and we get this moment equation. So we get moments from the load in the bucket, the cab weight, the motor weight, and also the force from the back wheels. And so from that, we actually wind up with only 2 unknowns in here. So we can figure out what FA and FB are. So FA is 75 kilonewtons and FB is 63 kilonewtons. So we have 63 kilonewtons acting on each tire back here, so double that for this total force. And then 75 kilonewtons acting on each front tire. So then they wanted to know the reaction force. So we got that, and then the force exerted on the motor unit at CD. So this is CD here. This is the coupling. So we need to figure out what these forces here, internal forces, are. So I just did a free body diagram of the motor unit. We could have done the cab, but there were more loads acting on it, so I just use the simpler case. We would get the same result either way. So what we have is twice, and again I should put a 2 here, twice the a load on each one of the wheels, plus the force in the coupling must be equal to the weight of the motor unit. And then I took torques about the back wheel here. So we have a torque from the weight, and we have torque from this force here, and a torque from this couple here. And so that gives us 2 more equations. We already know FB, so we can find FC and MC, and we find that FC is minus 25 kilonewtons, so it's actually down this way, and FMC is minus 310 kilonewton meters, so it's actually in this direction here. So we have a downward force acting on the back and a counterclockwise couple acting on the back.